Hi, I'm Brian. I'm TCMB 371 on the Alta Owners Forums and BW Haskell on Instagram. If you haven't already given me a follow, go ahead and do that. I do post a lot of videos on the bike and things like that. So head over there and give me a follow. So I thought I'd make another how-to video, this time explaining how to use the Alta MultiTool software. So if you haven't already installed the software, please visit the link on the forums here. I list out a link to the download provided by this gentleman, 416C7461. I also go over how to use VirtualBox, install Ubuntu, and install the software. And there's pictures that we'll be talking about today that you can reference. Okay, so prerequisite number one is, at this point, you'll need the data cable, and you can also get that right on the Alta owner forums by clicking this link right here. And in addition to that, you'll also need the CAN to USB adapter. So make sure you purchase both of these separately, and what you'll have is this piece as well as the computer side, or the CAN to USB adapter. So here's the CAN to USB adapter, and here's the Alta to serial, or CAN, if you will. So the bike gets plugged in right here in this port. So you'll lift the seat off the bike, and up here where the ACM is a little plug, and you'll remove that plug. It just pulls right out very easily, and it exposes the female cable here, and you just plug this end right into that port. In order to get all of the functionality out of MultiTool, you'll need to have this plugged into your computer before you start MultiTool, so that's why I'm saying it's a prerequisite. Alright, so I have my computer hooked up to my bike right now, so what I'll do is close this browser. Alright, so if you're using VirtualBox and Ubuntu, you'll first need to transfer the USB connection from your Windows machine or host machine over to the virtual machine. And to do that, there's actually two ways, but the way I'll show you is down here on the bottom right, you'll see this USB symbol, and what you'll do is you'll right click on that and you'll select the Lawesville CAN USB. What this will do is it'll transfer the USB device over to your virtual machine, so now it can be accessed inside the virtual machine. Alright, so now that we have the USB cable plugged into the computer and the CAN USB adapter plugged into the bike side cable, and the cable plugged into the bike, and the bike turned on, we'll go ahead and open up the terminal by hitting Control-Alt-T, and then we'll type sudo redshift multitool, hit enter, type in our password, and MultiTool will load. Okay, so here we are in MultiTool. I am using version 3.37.11.et. So you start out on the versions tab, and this screen displays some general version information about your bike. So it will actually show you your VIN number in some cases, and so long as you have the firmware file and the recommended firmware.json file in the correct firmware directory, and I will go over that. It will pull the recommended firmware from that file, and it'll also figure out what firmware you have installed on the bike. Okay, so you can see some basic bike information going down here. It tells you what type of cells, and then it tells you the versions of each individual firmware file for each microcontroller. So this is one way to verify which actual firmware you're using for each microcontroller on the bike. Down on the bottom, you can notice that the MultiTool has begun retrieving log files from the bike, and so every time you turn your key on, your bike is recording all kinds of information, and every time you hook up multi-tool to the bike, and so long as you're in these first few tabs, it will go through and download those log files from the bike. All right, so we'll dive over here into the Data tab, and this is where you can go and look at all of the log files that you've already retrieved from the bike. So what you'll do here is you'll select your bike here, and for your instances, it will parse all this information for you. I just actually copied these files from my main laptop over, so that's why you're not seeing it. I purposely did that. And so clicking refresh here after you select will display all of the log files that have been downloaded, so you can see a date timestamp of when they were taken, and I believe this is the start date of the log file. So if you pay attention to the times of your rides, you can easily find a specific ride. It also gives you the duration of the ride, or of the key on event, I should say, because it also logs if the bike is just sitting still. It will log all that information too. So you can also do logs when you're charging the bike, for example. And that's why you see some of my logs are 2 hours long almost. That's because I went out and did a ride for about 45 minutes worth of riding and popped it on the rapid charger and was charging it for the rest of the time. And so that's why you see something like that. So to view these log files, what you can do is you can select one of them. So I'll select one with some mileage, so you can see some actual bike data. And you'll go over here to the right side and you'll view the ride. And so what that does is it parses the log file and gives you the ability to graph and fly through that ride, basically. Okay, so now you can see we've entered into my log file here in the file view. And I'll expand this window a bit. Actually, I'll maximize this so you can see the whole screen. And so what you have here is your log file is loaded, but there's no parameters pulled into context. So that it's up to you, the user, to pull in the data points that you would like to see. So for example, here we are on the first tab, and this is the module voltages. So it actually splits each module of our Alta battery pack into 4, or actually 8 groups, I should say, so 4 halves. And so you can do the whole half of a module on the graph. So let's show you what that does. So there you have, it'll plot all those values over time on the graph. Or you can select individual P groups for that module. So let's just say you're kind of narrowing down into one of them. And notice that on attributes that you have selected, if you highlight over them with your mouse, it will change the color of that particular data point in the graph to red. So if you're really trying to just figure out, maybe there's a discrepancy in one of the values, it like spikes up or down or something like that, you want to figure out exactly which one, you can kind of just go through here and pinpoint by highlighting with the mouse. You can also apply an axis to the left-hand side. So that way you can see exactly what these values are. So you'll click on the checkbox next to this edit scale. And what that does is it puts a default scaled axis on the left-hand side with some minor dotted lines. And so here you can kind of infer over time, what these values are. Now, what you can also do is, let's say the part of the log that you're looking at, you only want to look at maybe a minute's worth of it. So you don't need, for example, the voltages of the battery won't change that much in a minute, right? So what you can do is you can edit the scale of this axis. And so let's say I really want to kind of like increase the resolution of this data point, what you can do is, let's say we'll set it to 3.8 as the low end, and let's say, we know it's not above 4.1, so we'll say 4.1. And now you can kind of see it in a much larger kind of resolution. You can really get detailed with it. So if you're really looking to do that, you can. So we'll go ahead and close that. And let's uncheck the voltage for a second. And we'll dive into some of the other tabs. So now you can see in the module temperatures tab that you can see a log of all of the temperatures that are recorded for the battery pack. So what we have inferred is that there's 4 quadrants on the PCB for each module. And so this is those quadrants, so 0, 1, 2, and 3. And then there are two other temperature sensors that we believe are kind of being pulled from opposite sides of the pack. But that's still yet to be determined. But what you can do is you can just pull all these temperatures in play. And for example, you can see that LTC temp 0 is a little bit higher than some of the PCB temperatures. And of course, we'll want to bring in the scale again. So here we can see the temperatures in Celsius. And, for example, in this small chunk of time, the bike LTC temp 0 got up to about 31 degrees or so. And you can see that. Alright, so next we'll dive into the Inverter tab, and for the rest of this demonstration I actually loaded a larger or longer ride so we can get a bit more data into view. So we'll dive into the Inverter tab, and let's go ahead and put motor RPM and throttle percentage and let's say motor temperature. And we'll add in the axis scales for all of these. And a lot of clutter is on the screen right now. So what you'll want to do is dial back the visible seconds to a much more readable scale. So I'll just go back to, let's say, 60 seconds. So here we have a 60-second view. And what you can do now is you can use the slide bar to kind of steer your way through the log. And so maybe a little bit difficult to see, but in the deep blue there we have motor RPM, so you can see the RPM raising and lowering. You can also see the throttle percentage, and you can dive through here, and if you really want to get fancy, you can dive down into 10 seconds and get a really granular look at things. Probably see some wheel spin events in here and things like that. And also the teal line is the motor temperature, so you can see that kind of gradually increasing as my ride goes on. And typically kind of less than 80 degrees is pretty good for an electric motor. From what I've read, up to 100 degrees is okay. So when you go in here and you look at things, don't be too alarmed about that. But just to give you an idea of what you might want to look for. All right, so we'll take these out of context again real quick by unchecking everything. And now let's dive into the ACM. Now in the ACM tab, this is your accessory control module, and this is basically what takes in all the inputs like blinkers and headlights and brakes and things like that. So quite literally throughout your log file, if your bike has these things, you'll see kind of digital on-off signals in the log file. So in a sense, it's kind of neat. You can see when you use your left turn signal, stuff like that. So next, we'll go into the Bcu tab, and this is the battery control unit. And so you can pull in values like min and max module temperature. So I use this pretty often because you don't really need to see all the individual P groups and things like that unless you have a problem and you're trying to determine where it's at. But min and max should do, and you may want to throw in state of charge as well. And so let's go ahead and back this out to like 100 and say 3 minutes, 180 seconds. And if we start cruising along here, on the top there, you can see the state of the battery charge kind of going down as I'm going on my ride, and it's going down, down, down. You can see the temperature kind of flatlining, and you see state of charge there. So now you have the two axes. You can see this particular ride, my battery pack got up in the 60s or so Celsius, which is pretty good. Looks like at this point it got a little higher. You'll notice that as you run the battery pack low state of charge, you will get a little bit higher battery temperatures as you continue to load the battery. So I would recommend riding the bike and kind of trying to stay above like 25% state of charge. This should help. And also after you charge the bike, especially rapid charging, it will heat up the battery a little bit. So if you can, kind of wait until after you charge the bike to let the battery cool a little bit, or if you can kind of spray some mister fan on it or something like that, battery powered mister fan with a bucket of water works well. Do that. Okay, so let's continue to dive through these tabs. I'll show you charger. So you can see things like the current coming in. So we can put these two into view, and let's find a section where I was charging the bike. Here we go. And so what you can see here is the charger current and the internal controllers limit. So you can see it's kind of increasing, stepping up. And just for fun, we'll put in state of charge as well. And here you can see that state of charge is increasing ever so slightly. So it looks like at lower state of charge or lower battery voltages, it applies a kind of slow, gradual amperage. So you can see here, it's only getting about 2 amps. Going up, up, up. As the state of charge increases, keeps going up. And looks like I stopped charging right at this point for some reason, and turned the bike off shortly after that. So you can see a flat line there. Alright, so you can pull in the, if your bike is a Supermoto and you have the onboard charger, you can see all of those values. So those of you that don't have that, they're not really pulling out any values, so they're not needed. Okay, so let's go over to DCCP. This is the DC charge port. So you can see the internal and external voltages. And so if we pulled open the scale, we can see here kind of the voltages that are being applied at the charge port. Okay, and often flags, you'll see if your I'll kind of just click all of these and kind of show you what that looks like. So you can see how the values appear on the graph, these kind of on-off values. And so you can see, for example, here's an inverter status of on, a charge result, things like that. So if you click on the screen again, You can see exactly what those values are. It looks to be hexadecimal of some sort. You can see all the raw information coming through. So that may be of use. So we'll go ahead and uncheck those. If you get any codes of certain kinds, they will also post on the log file. So you can see all of these. So you can also export a lot of the other data points that are being retrieved off the bike, and I'll kind of dive into these a little more when I explain the raw CAN and raw signal tabs. So there's things like accelerometer data, all the raw data points, there's about 450 of them can be exported to a CSV file. So you can individually select here or select all of them, or you can type in something. So let's say you only want to see BCU values. You can type BCU and it filters only those values. So that's quite nice. And then what you can do is select all of these. You'll notice in the export column, they're all selected now. And we can click export. And then you define a time range where you want to export these values out of. So let's say we want to do between 1500 seconds and 2500 seconds. We'll click OK. And now it prompts you to save it as a CSV. So you can then save it. And it'll go through and export those values for all those seconds. And so that'll allow you to do some outside analysis if you want, or something like that. And so real quick, we can dive into that directory and pull that open. And now you can see all of those values spread out across the columns, and at all of these time points, quite frankly, millisecond time points, you'll see all of the raw values coming through. So this file will be enormous if you just define a large time frame. But you can see all of the individual values that are outputted. So that's actually really nice. Maybe you can come in here and set some conditional formatting in the CSV file to kind of flag values outside a certain threshold or something like that. So just some extra tools for you to use. And this custom tab doesn't have anything in it. I'm assuming that this was a spot that would have eventually allowed third-party vendors from adding features in here or inputs to the bike, and then those would be captured kind of in this screen as accessory items. But that's just speculation. I'm not sure about that. All right, so if your bike is still plugged in and turned on, we can go over to the raw CAN values, and it's quite literally streaming in real time all of the raw values off the bike. And so in this view, you can actually see all the CAN IDs for these data points listed out here. So this is actually oriented seemingly in numerical order. And so for those of you who are looking for the CAN IDs for certain things, you can get all that information here. And then of course it spits out the raw hexadecimal data that's coming through. So this may help some of you decipher some of the inbound and outbound communication that's going on via CAN, and hopefully develop new displays and things like that. So then you can go over to the raw signal tab, and this is kind of the human readable versions of all the CAN information that's coming through. And so you can see in real time Looks like my bike's a little leaned over, and it is. It's on my triangle stand. But you can go through here and check out any and all of the 450 plus data points coming off the bike. So you can see right now my battery's highest voltage is 3.98, so individual cell voltage, and the lowest is 3.96, so pretty good. And all kinds of data. So I'm not going to go over every little bit. I'll leave that to you guys, and you can look at what's relevant to you for your purpose. And just a tip, you can also filter here. So let's say I wanted to see something with motor in it. You can see, okay, our motor temperature is 23.3 Celsius. And it does keep track of minimum and maximum values. So that's kind of cool to see what those min and max values are for your session. And you can clear the minimums and maximums. So let's say you're trying to test something and you want to see its effect just at that moment. You can kind of clear the min and maxes and establish a baseline, do the test, see what changes, something like that. All right, so then we go over to the dashboard view, and this is pretty neat. Kind of gives you a nice graphical view of what I think are the important data points on the bike. Let's say you're at the track or something and you want to see the state of some various components, or if you're running through some testing and things like that. I really think it was for dyno testing as well, so that's why you see the motor RPM and vehicle speed and things like that. But it does list out voltages for the battery as a whole and individual modules collectively, and the module sums, things like that. So on my bike, you can see it has 52 hours, and it also displays how much time you spent charging the bike. So mine just happens to be 189 hours. And this is real time. So if I was to twist the throttle, you would see the actual throttle readout. And if I had the bike on the dyno, you would see the RPM changing and the speed changing, things like that. So pretty cool little dashboard if you want to quickly view things in a graphical way. Maybe you just want to check, module temperatures or motor temperature, inverter temperature, or something like that. You can come in here and find that. So we have accessory loads. So this kind of just records what is loading the bike. So you always should see this pump turned on. That's your coolant pump. And when you have the multi-tool plugged in, it's likely you'll see this aux third-party device ticked off. But you push any of the buttons on the map switch, these will light up. If you have a bike with any of these things and you hit that function or press that button, these will highlight red to kind of let you know they're on. So it's a cool way to see, what the IOs are on the bike in real time. Another really valuable display, in my opinion, is the battery display. And this is where you see the voltages for each of the P groups for each module. So if we were to dive down and kind of adjust the scale here, you'll see I'll do 3.0 and 4.25. You'll see that I have a nice flat battery, really well balanced, and this is what you should see as well. These bars should be pretty flat across the board. If you happen to see some cells really super low compared to the others, you may have a wire bond issue that will need to be addressed. It wouldn't actually affect performance per se, but it will affect range on the bike, and that code will post over and over and over again even after you clear it. So it's one thing you probably should fix. But here you can kind of see the actual voltages of each P group for each module. So each color represents a module, and It lists out the min and max here for each module, and kind of sums things out here for you. And again, you saw me change the scale. You can do auto scale as well, which kind of brings it real close in, so you can kind of really see the minor fluctuations of the voltages there. So if you have any fault codes or check engine lights or any problems with the bike, besides I'm finding this here just represents you plugging the bike in. You'll see this highlighted. So let's say you do have the dreaded code 36. This basically will light up, and it'll kind of verify what you've done. So you can actually clear the codes by clicking clear BCU persistent faults. When you click that, notice that there's really like nothing to do here. So what you actually have to do is expand this window. It's just a little formatting bug that they had, and that's where you'll get the clear faults button. So you click clear faults, and if you have them, it'll disappear. Now, again, if you haven't actually fixed the issue, the code will come back in a short amount of time, because the bike is constantly doing verifications of all the different parameters to make sure that everything is in check. All right, so off on the loader tab, just basically lists out your individual versions for each microcontroller on the bike. So this is another quick way to see what firmware you have. And you can actually load the firmware updates through this here. However, I would suggest you use the one that's off in the versions tab. And in order to update firmware, you need to have the firmware files in a specific directory. So let me go ahead and take this time to show you where that is. So if you click your files button here, and you go to your Alta directory, your .alta directory, inside here you'll have to create a new folder called firmware. And if you go back to, I'm going to open a new window here. If you go back to your Alta and MultiTool engineering directory from that original download link, you'll have your recommended firmware.json and the firmware files for the various types of bikes. So just to demonstrate this, I'm going to drag this MX version over, and I'm also going to drag this recommended _ fw.json over. Okay. And so now what you'll do is inside this file, just wait for that to load for a second. Inside this file lists all of the VIN numbers for all of the bikes and the associated ACM serial number, and you'll see a spot listed here called target firmware, and this is where MultiTool will look to see what the name of the new firmware should be. And so this is Alta's way of kind of pushing out firmware files. So MultiTool would actually look on their server for this particular file that they would update on their end, and it would reference whatever target firmware they wanted for all the bikes out there, and go out and download this actual firmware package locally to the laptop. And then so the point of this is that perhaps in the future, if it can be figured out, there might be different firmware files or something. What you'll need to do is match the name of that firmware package to this target firmware spot for your VIN number. So you need to find your VIN number in this file, and then go shortly after that will be the target firmware. So let's say my VIN number, I'm not going to identify it, but let's say my VIN number was 543. What you'll want to do is go and look at the target firmware for that. So in this case, it happens to be here. And so what we would do is we would go ahead and change this to whatever name would be that package, and save this file and continue on. So then what we'll do is we'll close out all of this and we'll go to data and refresh this. All right, so we come back to the versions tab, and you'll notice that it has now pulled all the information that it needs. So it has the VIN number listed, and I'll have this blanked out in the video because I won't want to provide that. But you see the recommended firmware name is 151RC1, and the installed firmware name is 151. So my bike's already updated, but we'll go through and click on the update firmware button. And so what this first does is it shows you the release notes for that firmware package. So this is basically just a text file they include with the firmware package. You click start, and the process basically walks you through the steps involved. So it'll ask you to unplug the charger if your charger is plugged in. It'll ask you to turn the bike off and then back on, and then it'll go through and flash the firmware that you've selected onto the bike. Now that process takes roughly 15 to 20 minutes. So you need to be absolutely certain that both the bike does not turn off during this, as well as you don't lose power to your laptop or your computer that you have hooked up to the bike. That is absolutely critical. You don't want to run into any silly problems because your laptop died or something like that during this process. So while that's going on, you'll notice that on the display of the bike, the high beam light will start flashing repetitively as this is going on. So that's a good sign. That means it's processing through. So it's a nice way for you to see from afar, for example, whether it's still going through the process. And you also may hear the pump turn on and off. Just don't worry about that. That's normal. And you also may notice that during the firmware flashing period, the display will kind of show no miles or no hours or anything like that. And don't be alarmed. It is just doing a refresh of the display. So after it's finished, it'll put everything back. So that's basically it. It'll just run through that process. At the end, it'll say that it's successful, and you just click OK, and that's it. All right, so I think that goes over just about everything you need to know to get your feet wet in MultiTool. If you have any questions, feel free to reach out to me on the forums. More than happy to help you. And I hope this was helpful, and good luck.